So I would like to hand over to Ms. Padmini Ranawat. She's joining us all the way from Austria. Austria is a country which is very far advanced when it comes to sustainable waste management. They have actually banned the landfilling, so they are very sophisticated.
Good evening, ladies and gentlemen. I hope you can hear me and you can see me. Yes, as mentioned, I've come from Austria. My name is Padmini, and my background is actually economics, but I work for a consulting company in waste management based in Vienna, Austria. Austria is a small country in the European Union with approximately 8 million people. And it is known actually for its very high standards in waste management and its stringent laws. So today I would like to talk to you a little bit about the historic development of waste management in Austria and how it became what it is today, and maybe some of the important factors or things that could be of major importance to solid waste management in India. So this is an example of a paper and fiber production plant in the 1960s, when the public awareness about environmental pollution was not there yet. And you can see that there are significant pollutions to the air through the chemicals coming out from the stack. I'm sorry. And also from the solid waste just being openly dumped, which caused environmental damage to the soil also. You have problems hearing me? Okay. And as you can see, there is also wastewater coming from the plant, which was just let out into the nearby lake to the factory without any treatment. So within the course of time, since the 1980s, as awareness grew about environmental regulations, the plant was actually considerably was step by step turned into an environmentally sound waste-to-energy facility with cogeneration of heat and electricity. And the factory is actually even producing byproducts such as xylitol and vinegar used in food products. So this development towards sustainable waste management is also illustrated by the amount of waste being dumped or landfilled, so to say. So you can see actually in the beginning, in the 1950s and 60s, the development from wild waste dumping and the strong economic growth in those years, and the strong increase of waste during that time, until sanitary landfills were sort of developed, until environmental regulations were implemented around 30 years ago. And that marked the beginning of integrated waste management, leading to the reduction in waste disposal through prevention, recycling, thermal treatment, and the utilization of solid residues. So some of those regulations leading to the development, important ones were, for example, the guidelines of waste management put out in 1988, stating as objectives environmental compatibility, resource efficiency, minimization of landfill space, and also, according to the precautionary principle, waste treatment prior to landfill. And another step was the ban of disposal of hazardous waste in landfills by July 2001, with an exception, and the ban on disposal of waste exceeding 5% total organic carbon for new landfills by 1997, and restrictions for existing landfills until 2004, that with exceptions until 2008, and exemptions for stabilized residues from mechanical biological treatment. One important measure in the development of waste management as well in Austria was the introduction of a landfill tax dedicated to the remediation of old landfills and contaminated sites. So today, a lot has been talked about defining landfill tax and how to do that. So in Austria, another objective also was to provide an economic incentive to prevent, recover, and treat waste. And when the discussion was policymakers or having difficulties of defining what a landfill tax should be and how it should be, one can say that there are three main criteria for an efficient landfill, and that is a predictable increase over a minimum of 10 years, the tax progression according to environmental standard of the landfill, and the tax progression according to the quality of waste to be landfilled. In Austria, currently, the landfill lies at 87 euros per ton of waste. And on the right side, you can actually see the annual revenues this tax has actually brought into since 1995. And also you can see the impact of the ban of disposal since 2004 is also reflected in the graph. So this we've already heard a lot about today. I'll just be brief about this. So a future-oriented concept for integrated sustainable waste management includes prevention and source separation and collection of separated waste for technical treatment in order to achieve recycling and recovery, and only to the extent needed, controlled disposal of treated non-hazardous solid residues to landfill. So there was also a lot of discussion about separate collection today. In Austria, separate collection exists for green waste, for composting, food and kitchen waste, for biogas, recyclable materials such as paper and glass, construction waste, bulky waste, mixed municipal waste, and specific hazardous waste such as old batteries or old medicines. And we've also heard that not the entire, the part of the collected material, there are limits to the sorting and to the recycling of that. So after separate collection, further sorting has to be done in order to separate the non-recyclable waste components, which in Austria cannot be landfilled anymore, and so they have to be thermally treated. And the table also shows how much in percentage waste has to be incinerated. The next table shows the development of atmospheric emissions from waste treatment plants in Austria and Switzerland. And one can see that over the last decades, considerable progress has been made in the reduction of these emissions. This was due to environmental activism by NGOs, individuals, etc. Stringent laws, as you can also see, the level legal emission standards in 1994 in Austria, down below. And also due to technological developments, improvements in the technology. Environmental legislation in Austria is currently such that atmospheric emissions standards are actually stricter for thermal waste treatment plants than for other incineration plants with the same output. So the Austrian Waste Management Act requires emissions to always be within the limits achievable under state-of-the-art. So in Austria, there are 41 waste-to-energy facilities in operation, and 6 facilities are being planned at the moment. So for a small country like Austria with approximately 8 million people, one can imagine the potential for a big country like Austria. So there should be thousands of waste-to-energy plants in India. This is a topic that has been talked about just now from my previous speaker. So when planning incineration plants, waste incineration plants, generally they should be constructed at sites connected to industrial production facilities, which require heat supply actually throughout the year, or at sites connected to regional district heating or district cooling network. So this has already been said by Mr. Nima. Waste incineration plants that produce electricity only will achieve an efficiency of approximately 20-25%, whereas plants with cogeneration and of heat and electricity can achieve up to 80%. And Mr. Vogler and Mr. Nima have also mentioned that making new plants for cogeneration is a challenge in India that will be difficult. So one also has to look at the existing industries in the country and maybe consider, exchanging old boilers. That could be a start for waste management in India. So one example of a municipal waste incineration plant providing district heating to the city of Vienna is called Spittelau, and it is actually situated right in the city center of Vienna. The plant started operation in 1969, and after over 40 years of operation, the boilers are now being revamped, and so they are at the moment just operating with one line instead of two. This municipal waste incineration plant has a great firing technology, a fuel capacity of 85 megawatts, an efficiency of up to 90%, and can treat up to 780 tons per day. So if one compares the specific atmospheric emissions from heating systems, the waste incineration Spittelau in Vienna has got lower values than the other ones from decentralized firing based on wood, oil, and natural gas. And staying with the waste incineration plant in Spittelau, if you consider the CO2 emissions corresponding to the share of fossil and non-renewable carbon, then you will see that these are represented here with 319 kilograms of CO2 equivalent per ton of waste. So if you take into consideration the avoidance of greenhouse gas emissions from the electricity generated due to cogeneration, and the avoidance of greenhouse gas emissions from household heaters for generating heat by using district heating from waste incineration, and also considering the emission savings achieved through the prevention of waste, that waste that would have otherwise had to be landfill, then all in all one can see that there is a net reduction actually of 1,440 kilograms of CO2 equivalent per ton of waste. Generally, thermal waste treatment plants require consistent supply of waste, and therefore a system to store to store treated waste in an environmentally sound manner is needed. And this is an example of temporary storage of waste that is wrapped in cylindrical plastic bales to prevent gas exchange and to preserve the content. Sorry. Okay. Oh, I have a lot to say. Okay. Well, then let's skip this. Okay. So one. So when you are looking and investing into technologies for waste incineration, very important is that the technical concept should be based on state-of-the-art technology for that type of waste, and proof of successful technical operation of a similar type and size of the facility of a minimum period of 3 years. And the financial risk for installing an unproven technology are significant. What you have to consider are costs for immediate upgrading in case of insufficient performance, costs for installation of a system according to state-of-the-art in case of continuous failure, and costs for alternative treatment of waste during incomplete or malfunctioning of the overall system. Okay, so this shows the level of costs in Europe, as mentioned, and when planning a new waste-to-energy facility, a very important phase is the concept and the feasibility studies, because considering the investment cost of the plant and the cost of further operation and maintenance of the plant, you have to really look into the technical alternatives, and in order to avoid failures in consequence. Sorry. Okay, I'm going to skip this. So then. Finally, I would just like to highlight one event that is being held in June 2013. Oops. Oh, it's gone. Yeah, got it. Oh, yeah. Okay, sorry. One event that is going to take place in June 2013 is a study tour based on waste-to-energy, where 8 facilities in Germany, Austria, and Italy will be visited. And this seminar and study tour will be held by Mr. Franz Neubacher, a senior expert on waste management. So if you're interested in that, then there are folders lying outside, and we would be very happy to welcome you in this seminar and study tour. Thank you.
Thank you very much, Ms. Ranawat. She has very nicely shown the long path a country usually has to go until they reach an optimal solution. So for India, I think it will be important not to compare themselves with Austria, but with where Austria was 30 years ago when it comes to waste management. So just because they ban landfill does not mean that this should be an issue for India.